Hello, everyone. I'm Rebecca, and I'm here with my coworker Stu.
Hi,
And
everybody.
these videos are meant to be quick chats about cool things that are happening in Unison. They're casual, and we just want to showcase some of the fun stuff or mission critical stuff that is changing in the Unison ecosystem. So today, I'm really excited to chat about a Terraform like library in Unison. Stu, I'm going to ask you because you're the person on the team whose role spans both writing code and writing all of like the infrastructure stuff for the cloud. Thinking about this library, like what inspired you to tackle this particular piece of work?
Well, Terraform is the tool that we use for all of maintaining all of our deployments, which happen to be in AWS right now. I could briefly describe for people who aren't familiar with it, but
Yeah.
it's one where you basically describe what you want to have deployed. And what it does is it looks at what you said that you want to have deployed. It remembers what it thinks it deployed last time, looks at what's deployed now, and tries to rectify the three different sets of information. Saying so, it will go out there and say, "Oh, okay, you had me deploy a machine that was 4 CPU, and now you said that it should be 8 CPU. That means I gotta take down the 4 CPU one and create an 8 CPU one in its place, or something like that." Now, what inspired me to write this in Unison is that we kind of want a similar system for the Unison Cloud deployments. In that, what we have now is a nice and simple way already to describe what your deployments look like, and that's something we can already do very well. Is that we have you can write a nice function which says, deploy this, set this deployment as the default for this service and things like that. What we don't do a very good job, though, is, however, telling people how to clean up their messes afterwards. And part of the normal deployment process would be make a new deployment and assign it to a service, make a new deployment and assign it to a service. But what's not necessarily part of the normal workflow that we typically do is say, okay, now I can undeploy the old service or undeploy. So what this system would hopefully do is do what Terraform does, and that what it will do is let you describe what you want to exist, saying I want these cloud environments to exist and to have these services deployed and maybe have these daemons running, and it will then go and inspect what is actually running and will rectify the two.
Yeah, I'm definitely guilty of leaving all of my hashes around in my cloud deployments. So this is something that I would be very curious about, specifically like the teardown process.
It's a problem that I've found myself solving in the past before, where you've found that you've enabled developers to very quickly deploy software and test new things or create new stuff, but they don't necessarily clean up. And then you get an AWS bill a month later that says, oops, we need a way of cleaning stuff up as well. That's not going to be the case with Unison Cloud. There isn't, as you're deploying more things, it's not like we need to spin up more machines or anything like that if you're not using it. But it will help when you now go to the app.unison cloud, where you can look at everything you've deployed. And right now it might be that we show you, here's a whole huge list of hashes of things you
Yeah,
deployed. But
I have a bunch of unnamed hashes.
now this system, what it does is it keeps track of all those. So it remembers what all those hashes are and will help you clean them up. And then also the other part of this is that if you are done and you decide I don't want this project anymore, you can just say tear it all down for me.
So, you've kind of described like what problem is it solving. If we consider the model, like the difference between Terraform and Unison and this particular library, like there's a lot of similar nouns in this library. There's resources, there's
Yes.
providers, there's like these things seem borrowed from the Terraform ecosystem. And so I'm
Borrowed
curious
is a
if you.
very generous word, as we would say, pilfered. I did absolutely not just take inspiration from Terraform, but I knew that there's a reason that a lot of things are the way they are in Terraform. So I did absolutely was looking at their types when I was crafting ours. And they don't match up one to one. There's some things that are made a lot better by Unison, and there's some things that are awkward that they do that we can't do. Some of the big benefits are that, in Terraform, everything starts off as a string. It kind of has to, because it's sitting in a HCL file, which
Yeah.
is their own YAML. But in our case, we're going to make it such that when you're providing an input, you could provide a typed input. So it won't necessarily all be stringly typed.
Yeah.
And then there's other places where it's nice that we have an ability system where they have to do something like, say, hand you a bunch of function pointers for you to call to do various things. We can make an ability where you you can see exactly what functions you need to call.
Let's actually dive into the code and take a look at what some of these look like in practice.
Our system is very much like theirs in that there's basically 4 top level verbs, which is like validate, which is saying, is the thing I'm describing deployable? For example, if you are deploying a daemon, you have to say what environment it's deployed to. So if you haven't specified an environment, the validate stage would say, no, this is not a valid input yet. The next one would be plan, which would be, now that we've made sure we have valid input, we would see what changes we think we need to make. So that would do things like actually go out to cloud and say what things are deployed, and then say what things do I think were deployed by me, and what things do I need to do to make it look like the input. The next step would be apply. The apply stage takes the output of the planning stage, which is a list of things to do, and it actually tries to perform those tasks. And if it's able to, then it records that in the state to remember for next time you try to plan, validate, or apply, or destroy. And these verbs kind of cascade in that if in order to plan, you first have to validate, and in order to apply, you have to first plan.
Can you speak a little bit about what validating a service deployment means from like a I'm an application developer. I want to set up a basic HTTP service. It's got a database and it's deployed to like this particular cloud environment, like my prod
Sure.
one.
Now, this is something that comes from the Terraform parlance. We call them resources, something that this system is maintaining for us. And we describe what resources we want it to create. So one of the resources we may want it to create is a deployment. Now, to create a deployment, it's going to call the cloud.deploy function. And the cloud.deploy function takes as inputs what function are you deploying and what environment you're deploying it to. So if in your inputs you just never mention an environment, we're going to say this is invalid because one of the required inputs for this resource is an environment.
Okay, so this could stop me from like forgetting to database.assign my my DB to a particular environment or stuff like that.
What we could do is add some validation rules to say that if you've created a database and haven't assigned it anywhere, that's kind of useless and that's probably a mistake.
Mm,
I could see those things as being maybe warnings. It would be hard for us to tell that you deployed a service that was going to talk to a database that didn't have access to, because when you deploy a service, it's hard for us to know what it's actually doing.
I see.
But we could put together, out of these building blocks of these smaller resources, we could put together resources which represent some lower level ones. So, for example, we could perhaps create a resource that could be managed into the system that maybe represented a Volturno workflow. And that could then make sure that one of the required inputs might be what's the database, and it could make sure that the database is added to an environment which is assigned to the same place as the Volturno daemon, and make
Yeah.
sure that those things work. But that's next step down.
Yeah.
And one thing that this has been like a lot of those projects go, in that it starts off as I could kind of envision all the parts in my head and I can make this work. And then when you go and start implementing it, you realize that you are going to open many cans of worms along the way, which is why this is not a finished and working library yet. You start to do these things, and then you quickly realize that when you start to create these resources, you have to figure out what order to create them in. So fun things happen, like I found myself authoring a new graph library so that I could easily ask the question of what are the roots of this graph, or which to me represented what are the things that don't have any dependencies. And then, and then every time, every step along the way, you say, okay, great, I solved that problem. And you say, nope, I need to solve it in reverse for deleting things, because when you're deleting things, you want to delete them in the reverse order. It's been a fun process, and it's coming along. And right now, it only knows how to deal with environments, deployments, service names, and it does know how to do those in the right order now. But there's a lot more that can be added. But very much in the vein of Terraform, it's set up very similarly, where it's pluggable providers. So there's a set of types that you can implement, and you can make your own provider. So I'm providing a local provider, which only has files, so it handles local files. And then I'm going to be doing the cloud one, which should hopefully manage all the things you manage through the cloud ability, which would be, environments, services, daemons, databases, blob storage, and all those things. Now, theoretically, we could go and implement to providers that you might find in Terraform, like an AWS provider. And I think that could be kind of fun if
Mm.
we had all the time in the world. Don't know that we'll ever get there, but this is a system that would be capable of doing that.
Okay, so a provider is like the platform that you are describing these resources for.
Yeah, there's basically 4 different functions that you need to implement if you want to provide the ability to manage a resource. And those are actually CRUD. It's create, read, update, and delete. And there's a bunch of semantics that you need to follow about what it means to create and what it means to read. So there are a set of things you need to implement, but it's 4 of them. It is pretty straightforward, and it's the system's smart enough. If you just follow the rules and implement them correctly, it will know how to maintain them and manage the state for you, so that it can hopefully know when things need to be destroyed and when things need to be replaced and deleted and created
Yeah.
and so forth.
So, I mean, some of the complexity here, it strikes me, is in the translation between the stringly typed world and then moving it into the Unison programming model where you can declaratively describe like a certain configuration for the cloud.
Yeah, and I think that it should be that the working with a typed version, I think, should be strictly better. And of course,
Mm.
I might be a little bit biased in my history of interacting with computers towards typed systems, but I think that adding types to it should only improve the system. It's something where also, we can eliminate a whole bunch of annoying retry loops where you're going through just on the fact that we have a type checker that can help you make sure that your input is at least sane before you try to apply it, so you're not sitting there waiting for it to apply and saying, no, I can't apply it because you forgot this or you forgot that, or that's a string and it should be an int or whatever.
Yeah, agreed. Will we see uniform this library in cloud deployments or, you know?
I think it would be a nice way of describing cloud deployments the way that we do now, where you have a deploy function that says this is how you deploy it. I think it would be nice to be able to say, and here is a uniform description of the entire deployment. It might be a nicer recipe to hand someone than a big script that shoves all this stuff out there and doesn't tell you how to take it down.
I'm curious, as you're describing these declared resources in Unison, like in actual code, that transformation, obviously, great. We love types. Is there a way to transform the plan back into Terraform? Like, could we write the type thing and then produce a conf file?
That would actually be usable by Terraform.
Yeah.
Well, yes, we could do that for the types which map directly to provided types for which there are providers in Terraform, which
Mm,
now another thing that we have discussed is that one thing we could do would be to create an actual Terraform provider for cloud, so that in your Terraform you could deploy cloud things too. But none of us know Go. So, and there's not a lot of, I don't have a lot of, I'm not necessarily, I wouldn't be thrilled about doing that in HCL and strings instead of doing it the way I do now, which is to just write a Unison function to do it. Now, if we were to say, and it would be the same type of thing where, yeah, let's say that we did create providers for AWS or for, so you could create S3 buckets and EC2 instances and stuff like that. We could make it so that we make sure that we could easily map back out to the strings and create the Terraform to do that. But again, I'd question, why would you want to do that if you didn't have to do that anymore?
Yeah, it would be kind of strange if this library, the goal was to produce something strictly less descriptive than what we can do in Unison.
Right. It would be a lot of work just to be able to
to produce
to
a
not
conf
have to
file.
write HCL, which is a goal.
Yeah. Well, I'm really excited to see where you take this.
Let's see if Santa will bring us a functional uniform library this
Ooh.
Christmas season. We'll see.
Excellent. Well, thank you so much, Stu. Bye.
Bye.